diode and power diode. The diode is a semiconductor device. Already we talked about it. Semiconductor device, which is generally formed by the called as PN junction diode. Actual technical name is PN junction diode. Already we told, because why means it has two parts. One is N-type material, other is a P-type material. We know that P-type material means they have holes which is represented by a positive sign. Because of positive charge, it will be filled entire this one. Because you take pure silicon, dope it with pentavalent element like a phosphorus or this one, then it becomes P-type. That means excessive positive charges are there, which is called as P-type material. Then holes. Then N-type material, you would take the pure silicon, which is insulator, dope it with trivalent element material like aluminum something. In silicon, you dope. That means by heat the silicon vapor, almost it goes to close to melting point. That time you melt the aluminum, vaporize, the atoms will be go inside the silicon, pure silicon. It will replace this one. It get bonded, chemically bonded. The electrons will be shared. Chemical bond happens. That time you will get excess electrons. So then that is called as N-type material. Electrons are generally represented minus sign. We discussed about this, okay, in the previous class. So when you do that, we have the N-type material one side, P-type material another side. When first thing is you take pure silicon. Already I told you, I don't want to explain again. You take a pure silicon bar, and one part will be closed. Correct. One part will be insulated so that nothing can. They give a coating. Correct. Ceramic coat, some material are non-conducting and material, and this left side of allowed the generally if you think it is a cylindrical shape rod, correct, this portion will be covered so that nothing can go. This half alone you dope with the pentavalent element, correct. That means it has a 5 electrons outer mode, correct. The silicon has 4 electrons in outer mode. When you connect one excess electron, because will be created, then you become a N-type material, correct. So you fill it. After that, what they do, I'm just actual process is totally different for understanding purpose. Close this part, and then you heat the other half. You heat the other half, then aluminum in vaporized condition, atoms will be this one. The whole thing will be in a enclosure, correct. Almost vacuum, ultra low vacuum. No other material should be there. Sometimes what they do, they flush out with argon, all those things, clean out, then create a vacuum. Nothing else, even argon should not be there. Everything will be removed inside a vacuum chamber. Then they heat the aluminum, melt it, it become vapor. Atoms will be like a gaseous form. That will come and dope here. Then it will create the P-type material. Once it is done, as soon as you dope with the P-type material, this an aluminum, it become P-type. Already the N-type. As you are forming this central junction, this area, they attracted each other. They become what you call a neutral junction. It will become a neutral junction, correct. So that is called as a potential hill. Already we talked about it, correct. This is neutral area. No, both sides are because positive junction. So this is called as a junction. Okay, that means further electrons under the holes cannot move. Then diode become non-conducting mode. Of course, you attach a wire to this, and this is called as cathode. N-type material called cathode. P-type material is called as anode. Okay, so this already we know. Now, if already you have made the diode by doping, then junction is formed. That means the junction prevents the motion of electrons from N-type material to P-type material, and holes from P. Both will be attracted. but the junction prevents. Okay. Now, if I want to make the diode to conducting a diode means the electron should move like this. Electron from N type, the holes from P side should come. For that, what you have to give is you take the junction diode. You need to give external voltage. External voltage you have to connect like this. Already we talked about it previously. This is my N-type material. This is the P-type material. N-type material called cathode. P-type material is called anode. Anode will be connected to a DC voltage source. Please note that you cannot, for understanding, you can be connected AC or DC. But today we are going to what you call rectifier circuit. Main purpose of the diode itself to convert the AC voltage to DC voltage. Okay. But understanding, already we talked to say that if you give this one and I can vary the voltage, say 0 to 5 volt. Now, this is called as VDC. I can say V supply. I can say V supply. When V supply is smaller than or equal to 0.7, the diode will not conduct. That means electron will not flow. Now, if I increase this voltage, say 0.7 and above, say for example, Vs is equal to 0.8 volts. That means the electrons will move from here. The electrons will start coming inside this. Similarly, the holes from here will start coming inside this. Right? So now we say that the diode is conducting. When supply voltage greater than 0.7 or equal to 0.7, then if it is less than, it won't conduct. It is called non-conducting. Already we know that. When the voltage is greater than this one, it will become, we say diode is conducting. Diode is conducting. That means the supply voltage should be greater than 0.8. As you increase this one, once the current start, the diode start conducting, there's a current is going. I say that this is Vs. The current going through diode is called IDC. I diode. I can say ID. Many times I don't say IDC. I say I diode short form. I say that ID. ID is the current flowing through the diode. Right? That ID, how much ID will go? ID equal to, note down, V supply minus V diode. Okay, as the current start flowing, there will be some amount of voltage will be there. VD, the voltage, that is always by 0.57. Correct? 0.7 volts will be the I diode when diode is conducting. Now, if the voltage Vs is smaller than 0.7 and Vs will be same as Vd, diode will be equal to this one. For example, if the Vs equal to 0.1 volts, automatically Vd also will be 0.1 volts. Please note that during the time diode is not conducting. Whatever voltage you are applying, diode will be same as supply. Supply you are giving 0.1 volts, the diode will also there. Now, if the diode supply voltage is greater than 0.8, then diode start conducting. Once that happens, what will happen? The diode voltage will be always remain 0.7 voltage. I increase it to 0.9 volts, 1 volt. Like that, I'm going up to 5 volts. Whether once the voltage, supply voltage greater than 0.7 up to maximum voltage 5 volts, that's what diode is that. The diode voltage remain constant. Okay, diode voltage will become only this much. So what is current going? Now, once the current is start flowing, the diode also has resistance. We call diode resistance, note down. We always, previous class I said, RD. That means internal resistance of diode. Diode internal resistance. Okay. Now, this we already talked in previous class. For the sake of understanding or make you to remember that I'm talking about that, the RD will be equal to infinite ohms. Theoretical diode, the resistance unit is always ohms, whether it is resistor, capacitor, or whenever you talk resistor, DC resistor, ohms. So it will be infinite resistance, theoretical, correct? But in practical diodes, RD will be in the order of 10 into 10 power 6 to 10 into 10 power 8 or 10 also ohms, correct? This is called generally giga ohms, practical. That's also, you can see the very big number. Theoretically, the resistance should be this one. When the resistance will be this much, when Vs is lesser than 0.7 volts, that time the RD will be infinity theoretically. Practically it will be 10 megohm or 10 gigaohm, something, depending on diode characteristics, doping, all these things. So what is the current? The current theoretical, this one, ID equal to Vs minus Vd divided by RD, correct? So you are supplying Vs equal to say 0.6 volts, correct? And Vd will be same as this one. That means this voltage can be taken as 0.6, correct? The voltage. Then, Vs equal to Vd, we can see that Vs minus Vd is also 0.6 volts divided by, it is 10 into 10 power 6 ohms, correct? Numerator becomes 0, 0 divided by anything, correct? 0 divided by anything, we here 10 into 10 power 6 is going to be infinity, correct? Infinity or 0? Zero divided by anything.
0 divided by something is 0 only, sir.
Yeah, 0. So what will happen? My ID will be equal to 0. That means, that is why we say that when the supply voltage is lesser than 0.7, I say that my silicon, because this is made of silicon material, so it is called as silicon diode. Another diode last time I told germanium, GE, correct? And gallium arsenide is also now they are using for diode making. And Si. These are three materials used for making. They take pure silicon, pure gallium, or pure germanium, correct? Germanium diodes no more, but first diode inventor using germanium. Pure, all these things are insulator. They won't conduct current. So what they do, you do P-type, this one pentavalent or trivalent element, phosphorus or aluminum, and dope this one doping is done by melting both, correct? Silicon will be about to melt, correct? That is one. But the phosphorus or aluminum will be vaporized in a gaseous form, individual atoms, so that it can go inside this. When you do that, you will get gallium diode or silicon diode or germanium diode. Nowadays, silicon diode is very popular because of many advantages. Cheaper, availability of silicon is easy. You know that it is nothing but sand, correct? Sand has a lot of impurity. Melt the sand and remove the unwanted thing. Final product is nothing but silicon, which is insulator, in which you dope phosphorus or aluminum. I tested pentavalent elements. I gave 2 examples. Then they can make P-type and N-type material. By growing that, you can make the diode. Once diode is made, then you have to make this diode to conduct, means you have to give above 0.7 volts. Now, if the supply voltage Vs is smaller than 0.7 volts, we have from this equation equal ID will be 0. If ID, we know that if ID is 0, correct, then we say that diode is not conducting. Note down. Is not conducting. Now, if I give my Vd, correct? If my Vs is, say for example, 0.8 volts, and we know that the Vd diode, the voltage, this voltage is greater than 0.7, correct? Automatically diode will conduct. So across the diode, this is called voltage across the diode between anode and cathode, correct? That is what we are saying. Vd is not, this will be equal to Vs will be equal to Vd when Vs is smaller than 0.7 volts, correct? That is, diode is not conducting. That's what is this one. Now, I increase my Vs to 0.8 volts, correct? Which is greater than 0.7. I told you 0.7 volts in silicon diode. Silicon diode is called as cutoff voltage. Note down, is called as cutoff voltage. This is a correct technical name. That means if the voltage, that means supply voltage is less than, correct, is supply voltage less than 0.7, then my diode is not conducting. This voltage 0 to up to 0.7, 0.69999, whatever may be, correct? It is called as cutoff voltage region. And if the voltage is equal to 0.7, are greater than 0.7 up to what is called VD max. Each diode has what is maximum voltage can supply. By depending upon, there are more than 1,000 varieties of diode, different size with different voltage rating and different current rating. ID max and VD max and P diode, correct? How much power it can dissipate across the junction. These are the important parameter when you want to buy the diode, correct? VD max, for example, you take IN, correct? They say IN 7001, if I'm correct, I don't remember. This diode, the maximum voltage VD max for the diode is VD max will be 30 volts. ID max will be say 1 amps current, correct? PD max can be say for example 1 watt. Okay, this diode you can use maximum supply voltage applies the VS max will be equal to 30. That means you can apply 0 to 30 volts across the diode. Okay, the diode will conduct once my VS is greater than 0.7, 0.7, 0.8, 1, 2, 3, 5, 6, up to 30. If you apply more than 30, the ID max will exceed the diode current will exceed ID max, then diode will burn, get overheated, more power will be dissipated across diode, it will burn, correct? So that means you should not apply more than 0.7 volts for 1N7001 diode. For example, 1N7002, it can go up to 0 to 50 volts. Maximum you can apply like this. You can see the data sheet. This will be available in the data sheet. That is maximum voltage. But as long as the voltage is greater than 0.7, less than the VD max, then ID will be there. ID, diode current will go. That formula is VS minus VD divided by RD. Now, please note that once we supply VS is greater than 0.7, practical diode, this will be in the order of milliohms to few ohms, correct? Depending upon this one, it can be milliohms, 0.1 ohm, which are 100 milliohm, correct? Or it can be 10 ohms, 5 ohms, something like that, correct? This will be theoretically, this will be a practical this one. Most of the time, power diodes. If we talk about power diodes, the RD once the diode, what is this? When V is getting called diode is conducting, correct? Diode is conducting because my supply was greater than I gave 0.8 volts, correct? So what is my ID? ID equal to 0.8 minus 0.1 divided by RD. For example, this particular diode RD equal to 100 milliohms. Understand, 100 milliohms is nothing but 0.1 ohms. So that means 0.1, 0.8 minus 0.7 divided by 0.1. This is my RD for the given diode in conducting state. In non-conducting state, when the voltage is less than 0.7, already told you RD may be 10 into 10 power 6 ohms. Correct? In this case, we know that the current will be 0 because diode is not conducting. Because the resistance prevents current flow, that you can understand. In non-conducting, in conducting state, we know that it is 0.1 divided by 0.1. My current will be 1 amps current. ID will be diode current will be this one. Instead of that, if I say that my VS equal to say 5 volts, correct? What is my VD? When VS is greater than 5, my VD, already we told you, as long as the voltage above 0.7, whether 0.8, 1, 2, 3, 4, 5, the VD will be 0.7. So my VD is 0.7. My ID equal to, already we know, once diodes start conducting, the RD, I told 100 milliohms, correct? Nothing but RD equal to 0.1 ohms for this particular diode, one in conducting state. So ID equal to, we can substitute that. That is nothing but 5 minus 0.7 divided by 0.1, correct? That is going to be 5.3 divided by 0.1. You can see that enormous current, 53 amps current will go. ID will become 53 amps. But please note that what is the current allowed for this? For example, I am using 1N7002. This VD max equal to 50 volts. ID max for the day, if I remember correct, is 2 amps or something, or 1 amps exactly. So now heavy current is moving, then we need to control the current flowing to diode. Now it is conducting, but the voltage is within. What voltage we are giving? 5 volts. 5 volt is less than the VD max. For VD max, for IN 10700, it is 50 volts. So 5 volt is lesser than this one. The voltage is okay, but current needs to be controlled because the internal diode resistance is in the 0.1 ohms. Once for 1N7002 diode, the internal resistance is 0.2 ohms, and then heavy current will flow. Then we need to control the current. What we will do? That means this is my power supply Vs, which is varying from 0 to 5 volts. This is connected to my diode. This is 1N7002, and this needs to be connected to load, current limiting. We call load or current limiting resistor. It can be a load or a current limiting resistor. Then how will you select RL value? We know that for this diode 1N7002, VD max is, say I said 50 volts. That means 0 to 50 current. ID max equal to 2 amps, I said, right? That means what is the RD, current limiting resistance? This is called RL, load resistance. Please note that my RD during conduction state, it is 0.1 ohms, right? And if I put 0.1 ohms, if I supply even 5 volts, for 5 volts is how much current is blowing? You can see that when 5 ohms itself, we were saying very heavy current, 53 amps current, correct? ID become 53 amps. So that is not allowed because here the manufacturer only 2 amps. That means we have to connect an external resistance. This is external. Many books, they say external current limiting resistor. They call it external current limiting resistor or load resistor. What should be load resistance in this case? Now, to find out the load resistance value, correct, which is called RL or current limiting resistor, I can say R current limiting or CL, both are same. The RCL can be computed. The correct value of the ID, you can see that correct value for ID calculation is nothing but Vs minus Vd divided by Rd plus RL, because we are connected another resistance. There is a diode resistance internal, correct? It is called dynamic resistance, Rd, correct? This becomes infinity or 10 into 10 power 6, for example, or it become 0.1 ohms, correct? Practical this one. But so when it become 0.1, heavy current will go, then the diode will burn, even if you give 5 volts. But I can apply up to 50 volts. That means I need to provide an external resistor which is connected in series. This is called series connection, which is nothing but load resistance in series with power supply, diode, and load or current limiting resistance. How will you calculate that? The correct way is find out is this. This is the formula in which from this you can say that ID, the manufacturer already told 2 amps. 2 equal to, what is this one? They are saying 50 volts. Maximum supply voltage is 50 volts. 50 minus VD during conduction. We know that VD during conduction should be taken as, which is called cutoff voltage of diode, which is nothing but 0.7 volts. We saw in the transistor also, base to emitter when conducting, the voltage will be 0.7 volts. When the transistor, same thing you can use here, divided by RD is 0.1 ohms plus RL. RL we want to find out. So we can see that, I can say that from this, I can bring it this. So 0.1 plus RL equal to 50 minus 0.7 divided by 2. Okay. And I want only RL. So RL equal to, correct? This will go other side. 50 minus 0.7 divided by 2 minus 0.1. Correct? So this should be resistance value. So from this always you can say that, I can say that RL equal to, that is 49.3 divided by 2 minus 0.1 ohms. Okay, this is automatically we know the 2, 4, correct, 8 and 1, 3, so dot 6, correct. Something will come. We can subtract that minus 0.1. A higher decimal point we remove. So we'll say that my RD, correct? RD should be 54.5 ohms. Sorry, load resistance, RL. If you connect the load resistance equal to, as I calculate, 24.5 ohms, as you vary from voltage 0 to 50 volts, the maximum current flowing through diode will be limited to 2 amps. Correct? This is how you have to calculate the load resistance. Please note down this. You can expect simple problem. Okay. No, these are may look very simple, but many times many of you mechanical, electrical, but actually when you try to calculate, I see that when you do MTech project, the BTech project, even PhD scholar working, and actual implementation of circuit development, correct? See, my students are working with autonomous vehicle, scale down model. He is buying motors and he is buying this one, connecting load, all those things. Sometimes he burns, correct? He doesn't know the actual this one, how to connect, how to compute this value, load resistance, all those things. So please take this. So this is how the diode works.
Current value of RL, so current value of RL is 21.75, just for information.
Yeah, correct. Thank you. So this is how the basic diode is working. I wanted to explain quickly. Now, our interest is to know a little more. One more thing I want to talk about diode. When you talk about diode, the diode input-output characteristic they call input versus output characteristics of diode. Because it may, please note that many times, I don't mistake me. I have seen PhD scholar coming for interview, MTech interview, MS interview. For last 20 years, I'm the committee chairman member, all those things. You ask basics, many students, even after MTech, BTech, the electrical, you ask Ohm's law, you talk about Kirchhoff's law, basics we ask, so they forgot. So I studied first semester, second semester, I forget electrical technology, something basic electrical circuit. Nowadays, they're teaching in the school itself. 7th standard, 6th standard, physics, they are talking about Boolean algebra, all those things. But student, higher level coming for interview, if asked, they don't know. But I don't know how they will do design the circuit. That is the problem with India. That is why I am not trying to find fault. Many times students don't care. They say first year course, second year course, these are not needed. Hi-fi course, you talk about control system, is talk about AI, deep learning, all those things, without knowing fundamentals. If we talk about this one, mechanical engineering, strength of material, dynamics, kinematics, this course asks questions. One student, because last semester I was an interview committee, we interviewed around 30 students for MS and PhD selection. You ask anything basic, kinematic, dynamic equations, over. You ask this stress strain curve, over. Draw this stress strain curve of brittle material, correct, and ductile material and semi-ductile material. You ask the graph, stress strain curve. They would have studied the material science. They don't know. Mechanical engineer. But he talks FE analogy, I did this, did BTech project, many things are talking. But you ask basic thing, nobody knows. Literally, except 10%, many students are not able to hear. You talk about high level, they talk. I use this software, that software, will give graphs, many things, but without. That's why we are not able to build our own products. We are struggling. Correct? Small countries like Japan, Korea, correct, Taiwan, they are able to do. We need to. That's why But main reason is I'm not trying to say something bad about it. Don't think like that.
Sir, begging your pardon, but just wanted to mention that in automobile sector, like company like Mahindra, Bajaj, Tata, and I would say Hero Motors, they are doing wonders actually in that way, and we are challenging all the manufacturers.
No. I am not saying we are not doing products. You know, recently Anand Mahindra talked. I told you last class also, correct? Anand Mahindra, I saw a message in this one, public domain. Delhi Expo happened last month. This one, vehicle expo something. There, Japanese, Koreans, Germans, they are standing in front of the Mahindra electric vehicles. They introduced 3 vehicles. They were looking, sitting, because I saw the videos, Anand Mahindra mentioned. Correct. Generally, for last 50, 60 years, we go to international stores. And Indian manufacturer, Tata, all these people will engineers go and take photo of Honda, correct? Other foreign company products, correct? Now this year, and he showed people were standing in front of the Mahindra that stall and taking a lot of photos. International people for different companies because so good. I'm not saying that we are not able to do. That is not I'm trying to say. We can literally outperform anybody else, make our product and it's still better, correct? If you understand basics. Nothing more than that. I am also India. I am also, see, I got a job in US, correct? I got in green card. I said no. Year 2000. I have a top automotive manufacturing company I was working, developing embedded control. The company, the lawyer called me and said, we will apply for the green card in year 2000. I said, I am not interested. I will work only for 2 years. My interest is teaching in IIT Madras. I will go back. So I like India. That what I am trying to say is we need to put effort.
No, sir,
Correct?
just got a perspective, sir. No problem, sir. Just wanted to.
Yeah, I know that. I know that. What you are saying also, I understand. But still, you can do wonders. Correct? That is, I know that it is not that everybody is this one. Many of us are working under day and night, and we are producing good results. But everybody should do. Few of them working is not sufficient. That's what I'm saying. I told you, into also 10% of students are doing well. Correct? And remaining 70-80% are doing. That's what I want everybody to do well. Nothing more than that. Okay, so this is called as input output character diode. This region is called, because the x-axis is voltage, Vs, supply voltage. This is 0. This is positive side. This is the negative voltage, 0. Y-axis is the current ID. This is 0. This is positive side. This is negative side. Okay, so now this region is called as forward bias region. Okay, please see that the voltage is increasing positive. As you get this one, the current will start initially when Vs equal to 0, ID will be 0. That's what this is origin. As the current is increasing towards right, correct? Like this, you see that current start increasing. Correct? So now this will happen when current will not flow up to 0.7 volts. This is Vs equal to 0.7. This region is called as cutoff region. Cutoff region 0 to 0.7 volts. My diode ID will be 0. Almost equal to ground. Then once voltage become 0.8, this is 0.8 volts, for example. Then current start increasing. Voltage increasing, correct? Then current will start increasing, correct? Current will be 0, even though voltage. This region is called as cutoff region. This is the, I can say that maximum for this diode, for example, 50 volts. Correct? So here the maximum is 50 volts. VD max, we can VD max is the what is maximum? 0, this point. So the current reaches the maximum. This time the current is 2 amps. So this region is called a forward bias region. Now, instead of that, if I start increasing negative voltage, 0, I can apply, that is called, diode can be supplied with 2 type of voltage. This is called as forward biasing. Plus this is anode, this is cathode, and this is my V supply voltage connected to load, and this is my ID. This is my Vs. Okay. Positive of the battery is connected to anode, negative of the battery is connected to cathode via load resistance, RL. So the current is flowing. Okay. This is called a forward bias condition. Okay. Instead of that is nothing but this curve. Right? This curve is because of forward bias condition. I'm increasing voltage 0 to 50 volts. This is my 50 volts maximum voltage, doing the current increase 0 to 2 amps. And how will you protect the diode more than the current was? Using the load resistance. Already we computed for 50 volts and 0.1 RD equal to 0.1 ohms conducting state. Correct? In that case, already called 25 point something. Raushan, how much is it? 75, something you said.
21.75, sir. 21.75.
21.75 ohms. Correct? So for which diode? I exactly I don't know. I had 7002 diode. VD max equal to 50 volts. ID volts, ID max equal to 2 amps. This was the given. For that, you need to design this one series. Then only when I vary the voltage 0 to 50 volts, the current will not exceed, ID will not exceed beyond 2 amps. If the exceed beyond, diode will get overheat or burn. Protection. They call forward biasing. Instead of that, reverse biasing is like this. Positive voltage is applied to this is my load resistance. This is my diode. Correct. So this is my cathode. This is my anode. The battery positive is connected to cathode, negative is connected to anode through the load resistance. Okay. You see, the only thing is we say that diode polarity is changed. Anode is connected to negative. This is called as reverse bias condition. Okay, that means VS is negative, correct? It is negative lesser than 0, correct? Supply voltage lesser than 0. Okay, so that means this direction. This is the, now this is 0, this is -1, like that is goes. So say for example, this I say that -50 volts, correct? This point is called -50. I can apply up to 50 volts, minus volts. Positive side, I can give positive 50 volts in forward gear. Reverse also, I can give like this. Once the voltage exceeds 50, you will see that reverse condition, the current, you can see the, what is it? This is the current in negative direction, correct? Current in negative direction, or negative current, 0 minus current, correct? That means if current flows from the battery, it will be a minus current. So we say negative current. Negative current is 0. You can see that you increase voltage 0 volts. This is 10 volts, 20 volts, 30, 40. You can see the current is almost 0. Correct? Y-axis, negative side is 0 only. Close to 0. Maybe few milliamps. But once the voltage reaches 50 volts, you see that suddenly current is increasing. Vertical line. Right? You see that it goes. How much it can go? You should limit. This should be limited to -2 amps. That's what this resistor is going to do. Your diode will be protected because this one. So this voltage is called, this voltage, that is -50 volts, at which suddenly my diode start conducting. But it's not for the reverse bias conduction. This is called as Zener breakdown. They called as Zener breakdown. Zener is a person who invented the phenomenon. You would have heard about Zener diode. Correct? Zener diode can be used as a voltage regulator. It can be used as a voltage regulator. It can provide, for example, you give 5 volts. Correct? For example, I want 5 volts for my circuit, but I have a battery which is 12 volts. You cannot connect directly to 5 volts. So you can take a Zener diode, connect across the battery, then battery, the Zener diode will see that 12 volt battery or connected across Zener diode. I can show like this. This is symbol for Zener diode. You can see that normal diode is shown like this. Correct? This is cathode. This is anode. This is anode. This is cathode. You can see that something like this. This is the symbol for Zener diode. Okay? Zener diode, if you connect across a voltage source, because Zener diode is available for different voltage rating. So for example, I have 5 volt Zener diode. The cathode is connected to positive. Anode is connected to this one. Then if you apply 12 volts, if you measure the voltage across this using a meter, a voltmeter, it will give 5 volts only. If I remove the Zener diode, the battery voltage will apply. If I connect Zener diode, it regulates. So Zener diode can be used as a voltage regulator. Suppose I want 5 volt means I put 5 volt Zener diode. Instead of that, I want 6 volts. I put a 6 volt Zener diode. Zener diodes are available standard voltage, 5.1 volts, 6 volts, 12 volts, something. In market, you have to see. Correct? So nearest one you can get and you can regulate. So they are called voltage regulator. That is nothing but reverse bias diode. Correct? This is called as diode input output characteristics. You got it? So this is how it works with the basic, because what is input? Input is a voltage we are supplying. Voltage supplied to diode, VS, supply voltage. Output is a ID. Correct? I can say the VD is input. Correct? VD is nothing but VS minus VD is the applied voltage, output is IDS. So that's why this curve, you can take this curve, note down in the exam, you can expect. Draw the input-output characteristics curves of forward and show the forward bias, reverse bias regions, and also compute the current, all those things what we have talked. Okay. So you can talk about this. So main things alone I'm showing, remaining I'm removing. Okay. So Zener diode you can forget. I just for information, we are talking about diodes. So diodes alone you can note the forward bias, reverse bias diode. You can note down that. What is reverse bias? You can see the anode is connected to negative of the battery through load resistance. Cathode is connected to positive of the battery. In this case, this is called reverse bias region. This is called as reverse bias region. Please see that the diode current up to breakdown voltage. This is called a breakdown voltage or Zener breakdown voltage. Zener breakdown voltage is the what is maximum voltage you can apply across anode and cathode of the diode, while anode is connected to negative, cathode is connected to positive. Forward bias is nothing but anode is connected to positive, cathode is connected to negative through load resistance. I can vary 0 to 50 volts. Similarly, in reverse bias, I vary 0 to minus 50 volts. which gives 5 volts. Here, I can apply 0 to 30 volts. I can apply 0 to 30 volts at the input when the input, that is called V in. This is V in or supply, V supply. Okay, when V supply is less than or equal to 5 volts, because this number says what is regulation voltage. You have 7805, 78, this 06 and 09, 12, 15, 24. These are the voltage regulator ICs. These are ICs special because it's not single diode. Lot of circuits are there. But before invention of these ICs, please note that ICs were invented only 60 years before. The Zener diode is available last 100 years. Correct? Diode came 120 years before or something. Correct? Then to regulate the voltage, they invented Zener diode. The person name is Zener. I think German or Italian or European fellow. So that scientist. So honor him, they gave Zener diode. By reverse biasing the normal silicon diode, it can act as a voltage regulator. That's what this VI curve I talk. Correct? So when you apply the breakdown voltage, that time, so there are different breakdown voltage available. Right? This is, for example, 5 volt Zener diode. This may be 12 volt Zener diode. Correct? So different breakdown voltage, reverse bias apply, it will automatically, once voltage, input voltage exceeds, in both the cases, whether 78 some voltage regulator ICs, they call as voltage regulator ICs. Okay, these are available only these numbers, nothing will be available. 78, you cannot go on to 7810, 7813. Fixed voltage, they are called fixed voltage regulator. So this will provide, if I give the input voltage like this, correct, my input I am varying 0 to 30 volts, my output will always be 5 volts. This I can give to say a microcontroller, embedded controller, which need 5 volts, but my battery is 12 volt battery, correct, car battery, or 24 volts. If I give also, the output from the voltage regulator will be 5 volts. It is similar to using Zener 5 volt Zener diode. Okay. Now that we understand how the diode works, one small thing before closing, the ID when forward bias condition, correct? We are in diode, we are talking about Zener, I'm not going to talk. Diode, forward bias, ID equal to can be computed using this formula. IS into E power minus E power V by N into VT minus 1. So this is formula. This is called diode current. This is formula. Okay. Here, IS, in this formula, IS is called as diode saturation current. This is nothing but at reverse bias condition. If I take a diode at reverse bias it, what is the current going? Generally, it will be in the order of milliamps to microamps. Very small. Okay. Depending on diode size, power rating, voltage rating, all those things. So this will be given by the manufacturer. In the data sheet, you can find out. Then this is VD. We can say feed substitute. VD is the diode voltage. What is voltage you are applying across diode? We can apply 0 volt, 1, 2, 3, 5 up to we can maximum voltage VD max equal to 30. Correct? That what is voltage you apply at given time? Depending upon the current will vary. Then we know that N is called as ideality factor. Ideality factor. Generally, this will be taken 1 or 2. The value will be 1 or 2. The manufacturer data sheet will say what should be value in this equation. In the denominator N is there. That value, whether 1 or 2, the manufacturer of the diode will say. Once you know that, then VT is called as thermal voltage. Okay. VT can be computed using this formula. It is called KT divided by Q. Okay. Where K is called as Boltzmann constant. You know, Boltzmann constant, you would have written physics books. Boltzmann constant. K constant. Value is nothing but 1.38 into 10 power minus 23 joules per Kelvin. This is unit. K, which is called Boltzmann constant. Q is the electron charge. Q, you know, the 1.6 to 10 power minus 19 coulombs. 1.6 into 10 power 19 individual electron, how much electric charge it holds. That much you know. Correct? T is the temperature of the diode at any time. Correct? So, for example, morning, my room temperature keeping my diode maybe 20 degrees. Afternoon, it may be 35 degrees. Correct? This is temperature of environment or diode where this is. So, if you know that, using this, you can compute the diode current flowing through it at any given time. Okay. I stop here. Tomorrow we'll start. Next class, Monday. Okay, Monday we'll start about diode as a rectifier. Correct? Half-wave rectifier, full-wave rectifier, bridge rectifier, three-phase rectifiers. How to calculate voltage, current, rectified, all those things. We'll see for next two classes. Okay. Thank you. If you have any question,
Tuesday. If the Viva was ended by before 6 o'clock, we will join. Otherwise, we can start by 6:30, sir.
I will open my this one by Zoom link by 6. I will wait up to 6:30. Okay.
Right, sir. Right, sir. Right, sir. Right, sir.
As soon as
Before
all
that,
of
I
you
will
come,
call you.
immediately we'll start. Earlier is better,
Right.
so that you can go home
Right.
quickly.
Right, sir. Right, sir.
Okay. Thank you.
Sir,
See you on
tomorrow. Sir, tomorrow we have a class, right? Correct.
Well,
Thursday. Components.